Hey everyone, welcome back. This is lesson 10.3. I hope that you already watched the pre-lesson on conic sections just to review what an ellipse is. And so now we're going to get started on lesson 10.3, ellipses. The objectives for this lesson, you're going to be able to write the standard equation for an ellipse. You'll also be able to graph an ellipse and identify its center, vertices, co-vertices, and foci. Your vocabulary for today is ellipse, focus of an ellipse, major axis, vertices of an ellipse, minor axis, and co-vertices of an ellipse. If you pulled the center of a circle apart into 2 points, it would stretch the circle into an ellipse. So an ellipse is kind of a squashed circle. Now, I hope that you watched the other video because this will make much more sense if you've already seen the other video. So an ellipse is the set of points in a plane such that the sum of the distances from any point P on the ellipse to 2 fixed points, F1 and F2, and I called them F and G in the last video, called the foci, is the constant sum. So in other words, this formula is the distance equals the distance from point P to F plus the distance of point P to F2, F1 and F2. And again, I called it F and G. This distance D can be represented by the length of a string connecting 2 push pins located at the foci. So please watch the other video and you'll get a much better understanding of what that means. You can use the distance formula to find the constant sum of an ellipse. All right, so let's do that here. So we're going to use the distance formula to find the constant sum of an ellipse. And again, if you did not watch the pre-video before this one, please go back and look at that first so you understand what I'm talking about. So in order to find the constant sum of an ellipse, we have 2 foci, F1 and F2. And so F1 is at 3, 0, and F2 is at 24, 0, and a point on the ellipse, which is 9, 8 in this case. So first of all, the definition of the constant sum of an ellipse is this formula, from point P to F1 plus from point P to F2. We're going to find both of those distances, add them together, and that will tell us what our constant sum is. Okay, so we're actually looking for this constant sum. All right, so using the distance formula, remember the distance formula comes from the Pythagorean theorem. So we're going to take the difference of the x's plus the difference of the y's for the first set, and then the difference of the x's plus the difference of the y's on the second set, add them together, and that will give us our total distance. All right, so let's just go ahead and substitute all the information that we know. So notice my x is from P to F1. So here's my F1 and here's my P. So I'm going to take 3, which is right here, my x minus 9, and then I'm going to take 0 minus 8. All right, I'm going to add those up, and then on the other one, I'm going to take my 24, again, take my difference of my x's, so it's going to be 24 minus 9, and then 0 minus 8. Square those. So once I substitute and actually simplify that all out, I get the square root of 100 plus the square root of 289, and that is actually, square root of 100 is 10, square root of 289 is 17. Add those up, so my distance is 27. And that's all we have to do, so we know that the constant sum is going to be 27. All right, so try this one on your own. Turn your video off and give it a try. Same exact thing. All right, again, you're trying to find the constant sum for an ellipse. So we're given 2 of the foci and a point. So we're going to have to, first of all, use the definition of the constant sum of an ellipse. So it's from P to F1 and P to F2. We add those together, and that gives us our constant sum. So let's remember what our distance formula is. There it is. And so now we just need to substitute in. So I'm going to say 0 minus 0 squared plus negative 8 minus 10 squared. And that gives us this piece right here. All right. And then we're going to do it again. we're going to say 0 minus 0 squared plus 8 minus 10 squared. And when I simplify all of that, I end up with D equals 20, so my constant sum is 20. Hope you were able to get that one. All right, instead of a single radius, an ellipse has two axes. The longer the axis of the ellipse is the major axis and passes through both foci. The endpoints of the major axis are the vertices of the ellipse. The shorter axis of the ellipse is the minor axis. And again, I had examples of this on the earlier video, so make sure you see that. The endpoints of the minor axis are the co-vertices of the ellipse. The major axis and minor axis are perpendicular and intersect at the center of the ellipse. So this is important to know. All right, before you can write the equation in standard form of an ellipse centered at 0, 0, I want to talk about some things that you're going to need to know, because it depends on whether the major axis is horizontal or vertical. So let's look at the horizontal picture first. Notice that this horizontal is a little bit bigger, so our horizontal is our major axis. And so the vertex is at A0, and so the vertex of the major is going to be this A, a negative A, all right, but they're the same distance apart. And the co-vertex, that's going to be our B. So if the minor axis here is the vertical part, then that's going to be the B. So that would be our Y section of this, okay? So A, if it's horizontal, B for the major axis, and B is going to be the minor. Now, when we have a vertical ellipse centered at 0, 0, this time the major is going to be the Y, all right? The A is going to be the major. So I always remember A is the major side, all right? So A is the major. The co-vertex is going to be this B, all right? So co-vertex is always the B. The major is always the A, major A. And we can see our focus on both of these. The focus is always on the major axis. So in this case, in the vertical side, the focus is at 0, C and 0, negative C. Over here, again, our focus is on the major axis on the horizontal, and so it's at C0 and negative C0. So it's important for you to understand all of the parts of the ellipse before you can write your ellipse in the equation of ellipse in standard form. All right, so the values A, B, and C are related by the equation, and this is a pretty important equation for you to memorize, and it's not that hard, but it's C squared equals A squared minus B squared, all right? So you'll want to know that. Also note that the length of the major axis is 2A, so the length of the minor axis is 2B, and A in this case is greater than B. So let's take a look at the equation. If it's horizontal, it's going to be X. Okay, remember horizontal, the major axis is A. So the X is over the A squared plus Y squared over B squared. Now notice if it's vertical, all right, and that means if it's vertical, that means our major axis is on the vertical, which is with the Y. So Y squared is over A squared plus X squared over B squared, because B squared is now the minor, all right? So notice that the A squared is going with the Y squared because it's vertical, all right? And that's where your major is. The major is on the vertical, which is the Y squared, okay? And then your vertices are going to be at A0 and negative A0 for horizontal, or for vertical, your major vertices are at 0A and 0, negative A. All right, and the foci, if it's horizontal, okay, if it's horizontal like this, where your major axis, then you're going to have your foci on the major axis. And again, if it's the vertical, then your foci will be here and here. They're in the same place with your major axis. And then the covertices are going to be on the shorter side. Okay, I know that's kind of difficult for you to see, so let's just keep moving. All right, so let's do an example here. Using the standard form, remember we just saw the standard form to write an equation for an ellipse. So we're going to write an equation in standard form for an ellipse with a center at 0, 0, and a vertex at 6, 0, and a covertex at 0, 4. So let's think about what that's going to mean. So step one, we're going to have to choose the appropriate form of the equation. Is it going to be x squared over a squared plus y squared over b squared equals 1? If that's the case, this is x is with the a, so x is the major, and that would be an ellipse that looks longer like that, all right? Or is it going to be, here's our other equation, y squared over a squared. The major is with the y, plus x squared over b squared equals 1. So notice that the vertex is at 6, 0, and that's larger than this 4. So the x is larger than the y, so the major axis is going to be with the x. So we're going to use this formula, all right? The major is with the x. So we choose the appropriate formula. The vertex is going to be on the x-axis, and here's our formula. X squared over a squared plus y squared over b squared equals 1. All right, so once we've chosen which formula to use, we have to identify our values of a and b. So let's take a look at it. The vertex, they told us, was 6, 0. So that gives the value of a is going to be 6. All right, so a equals 6. All right, we also know that the covertex, that's the minor axis, is going to be at 0, 4. So the value of b is going to be 4. All right, so now that we know that, we can just fill into our equation, and we're going to substitute values. And so we already know that this would have been x squared over 36, because 6 squared is 36, plus y squared over 16 equals 1. And there you have written your equation in standard form of an ellipse. All right, now using the standard form to write an equation of ellipse number 2. Again, we're going to do it. This time we have a covertex at 5 and a focus at 0, 3. So let's talk about what that means. A covertex at 5. So first of all, we have to choose the right equation. So remember, if the major axis is horizontal, that means it's this length, it's going to be x squared over a squared plus y squared over b squared equals 1. So this a is going to be our major axis, and this would be if the major axis was horizontal with the x. All right, if it's vertical, then our a, the longer one, is going to be the y. So then it would be y squared over a squared plus x squared over b squared equals 1. So let's look at what we have. We have a covertex. That means that's the smaller one. So that means this is going to be our a. Actually, this is going to be our b, because it's the smaller one, because it's the covertex. And our focus is at 0, 3. So let's see where 0, 3 would be. Over 0, up 3. 1, 2, 3. So we know that our major axis is going to be vertical. So we're going to use this formula right here. All right. So choosing the vertexes on the y-axis. So we know that the formula we want to use is y squared over a squared plus x squared over b squared equals 1. Now we can fill in the information that we know. We can identify the b and c this time. All right, so let's identify b and c. So b is, we know, going to be 5. All right, the covertex gives us the value of b, which is 5. And now how are we going to find c? And actually what we need to have is a, but I have c, which is the foci. Now remember, we had that little formula a minute ago that said c squared equals a squared minus b squared. So if we have an a squared and a c squared, we can substitute, use our algebra to find our b squared. So let's figure out what the value of c is going to be, and that is going to actually be 3. So now we're going to use our formula. Let's turn to the next slide. All right, so here's our relationship. C squared equals a squared minus b squared. And we need to find out what a squared is so we can complete our equation. So we're going to substitute 3 for c and 5 for b, and go ahead and solve for that. And so we see that a squared equals 34. And so now we can write our equation. So we're going to substitute the values that we know into the ellipse equation. So we have our a squared, which is 34, y squared over 34 plus x squared over 25, because we remember that that was 5, so 5 squared is 25. And there's your final equation. All right, so try this one on your own. Turn your video off and give it a try. Think about what you have. Okay, so let's talk about this. Our vertex is at 9, 0, and our covertex is at 0, 5. So which is it going to be? Do we have a major axis on horizontally or a major axis vertically? Well, looking at this, it says my major axis is vertical because that 9 is bigger than this 5. So actually our major axis is horizontal. So we're going to choose the appropriate equation, and since that is a horizontal, our equation is going to be x squared over a squared plus y squared over b squared equals 1. All right, so next thing we need to do is identify our a and b, and it said that the vertex is at 9, 0, so we know a is 9, and we know that our covertex is at 0, 5, so we know b is 5. So now it's really easy. We just have to fill in the blanks into our equation and substitute, and we end up with x squared over 81 equals y squared over 20 plus y squared over 25 equals 1. And that's your answer. All right, here's another one for you to try out on your own. This time we have a covertex and a focus. So our covertex is at 4, 0. All right, so keep that in mind as you try this one on your own. So turn your video off and give it a try. Okay, so again, I hope you noticed that the covertex tells us the minor axis. So that means the 4 is going to be our B. All right, and we don't have an A, a major axis, but we do have our focus, so that gives us our C. And so let's go ahead and choose the appropriate form. If the vertex is B, so the vertex is on the y-axis, so we're going to use y squared over a squared, because the y is where our major axis is, over x squared, plus x squared over b squared equals 1. Step 2, we need to go ahead and identify our values of B and C. And we know the covertex was 4, 0, so that gives us the value of B, because covertex is the minor, and the minor one is going to be 4. So our B is 4. And we don't have our major one, but we do have our foci, or our focus. And the focus is at 0, 3. So that tells us C is 3. Now let's remember what our relationship was. So step 3, use the relationship C squared equals A squared minus B squared. And that's what we're going to use to find our A squared. So when we substitute in the information that we have, we find that A squared equals 25. Now I have my A and B. And so now I can write my equation for my ellipse. So substitute in y squared over 25 plus x squared over 16 equals 1, and that's my equation. All right, ellipses may be translated so that the center is not at the origin. And so again, we're going to have to follow a little bit of our formula here. This time we're going to deal with the top part, x minus h plus the y minus k, and both of those are squared. And the center is going to be at hk. So h and k. And sometimes I get confused with these minuses, so I always just think what number would make this 0. So if this number was x minus 3, I know that a positive 3 would make that 0, so my h would be positive 3, which is right there. If the problem said x plus 3, I would say what number makes that 0? Negative 3. So then the h in that case would be negative 3. So whichever way, I just like to look at it that way. If you can understand it the other way, then that's fine. Notice on the vertical, okay, I have to put my y first when I'm doing that vertical because it's with this. So my y is actually with the k. All right, so make sure that you notice, and my x is with my h. So x is always with the h and y is always with the k. It's really important that you don't get that part confused because you could easily make a mistake if it's written in yx form in this case. All right, so here's an example, and this problem says to graph the ellipses. So let's take a look at all the information that we know. So first of all, we need to rewrite the equation, and we're going to rewrite it in the formula that we know with our squares on the bottom here. All right, and so now that I know this, remember what I just said. What number would make this 0? Well, that would be a negative 4. Plus 4 would be 0. And what number would make this 0? It would be a positive 3. So x and y are in the right order. So I can see where my center is going to be at negative 4, 3. All right, so I've identified my h. I've identified my k. All right, and now I need to identify my a and b, and that's pretty easy. The a is 7 and my b is 4. So h is negative 4, k is 3, so that's the center at negative 4, 3. And now we see that our a is at 7 and b is at 4 because 7 is greater than 4, so the major axis is with the x, which is horizontal. All right. So now that we know what the center is, that our center is going to be at negative 4, 3, we can start to graph this a little more. So what we're going to do is we're going to say, all right, well, here's our center at negative 4, 3. And to find our major axis, it says that it's going to be plus or minus, this was 7 squared. So we're going to take our negative 4 and go plus 7, 1, 2, 3, 4, 5, 6, 7. It gets us at 3, 3. And we're going to go negative 4 minus 7, which gets us at negative 11, 3. All right, now for our y-axis or our co-vertices, we're going to start here at our 3, and we're going to go plus or minus 4. So 1, 2, 3, 4, that gets us at negative 4, 7, and minus 4 is going to get me at negative 4, negative 1. So that's how we get our 2 points here. All right, that's how we graph it. Okay, so try this one on your own. Turn your video off and give it a try. Okay, so on this one, the first thing that you should have done is figured out how to rewrite the equation as it will be. So we're going to see that we're going to have plus or minus 8 on our x and plus or minus 5 on our y. Notice that I have zeros here, all right? So that tells me that my center is going to be at 0, 0. So let's continue on. We got to identify our h, k, a, and b, and we just identified our h and k as 0, 0. And so the center is at 0, 0, and our a and b are going to be 8 and 5. And notice that my major axis is horizontal because the 8, which is matched up with my x, is larger. All right, so now we're going to graph this. The first thing we want to do is go ahead and put our center in. All right, and for our vertices, we're going to go on the major axis is x, so it's horizontal. So we're going to go 8 plus or minus 8. All right, 1, 2, 3, 4, 5, 6, 7, 8, a point here, and 1, 2, 3, 4, 5, 6, 7, 8, a point here. For our minor, it's going to be plus or minus 5. So we're going to go plus 5 and minus 5, and that's where we get our 4 points. All right, try this one on your own. Turn your video off and give it a try. Okay, again, the first thing you needed to do is rewrite your equation in a form we can use better. So I just changed this to, the only thing that I did was change that to 5 squared and 3 squared, so I know to plus or minus 5 and 3. Okay, again, we need to identify our H, K, A, and B. So our H this time is going to be 2. So what number would make this 0? It would be 2. And what number would make this group 0? It'd be positive 4. So 2, 4. As far as our A and B, we can see that A is the major. It's in the horizontal. So A is 5 and B is 3. And since A is with our horizontal, the major, it's going to be horizontal. All right, so now we can graph this. Again, we need to first find our center, and it says it's going to be at 2, 4. So come up here to 2, 4. All right, to find the horizontal points, we're going to say we're going to say plus or minus 5. So we're going to start here, plus or minus 5 gets us to 7, and minus 5 gets us to a negative 3. On the vertical, we're going to be doing 3, so we're going to start at our center and go plus 3 and minus 3. And there's all of your points. And that is the end of this lesson for today. I hope you learned a lot, and if you still are a little confused, go back and look at the first video again also. All right, I'll see you in class tomorrow. Have a good day. Bye.